Alright, part 2, the end. So you're tasked with graphing that thing. Somebody close the door. And all you gotta do is realize this thing is in vertex form. It is given to you in the form y equals a times x minus h squared plus k. So just kind of line things up, kids. You know that hk, remember change sign when you leave, is 5, 2. And that is your vertex. Now, vertex is the middle of a parabola. So I'm going to put those coordinates in the middle of my table. And the way I've been training you all this year is to count one to the left and count one to the right. So, if you're kind of bad at the math, you can use your calculator. I'm going to take that 4 and I'm going to plug it in for x. I'm going to use a storage feature. You don't have to use a storage feature. Take a 4, store it to x. Is the door not locked? Oh, Elena's back there, isn't she? She's so short. You just can't see her. And I'm just typing the equation in. Anyways, should get 1.5. That's what we got when I did it by hand. So 1.5. And the deal is these points match. If that one's 1.5, so is the other one. So my points that I'm going to plot are to the right 4 up about 1.5 units, to the right 5 up 2, to the right 6 down up about 1.5 units. And the thing opens down. Looks something like this. Makes sense that it opens down. There's a negative symbol up front, just little things like that. A domain, I might actually have this wrong on the key I gave out, but actually I never labeled it. The domain of this thing is that we run from negative infinity to positive infinity because it runs forever left and forever right. And the range is that it comes up from negative infinity all the way until y hits a value of 2. And that is a point that exists. So there's your domain and range. Number 11. So there's some text there. You can read that on your own, right? But there's some information given. You're going to throw your book to the edge of over the edge of a building to a reflecting pool 200 feet below. Well, that's your initial height. So we call h0. And this 40 is your initial acceleration. So part A is an easy thing. Just plug stuff into an equation and show me the equation. Now part B and C I'm going to do with TI-84. Over what interval of time will the book's height be at least 50 feet? If I was doing this by hand, I would take my equation and I would say it is greater than or equal to 50. That's how it would be done by hand. So it's kind of how I do it with a calculator. At least I use that ability to do it in the calculator. I put that in Y1 and I put that in Y2. And you should play along. I'm going to do a zoom 6. I'm not going to see anything. For one, this thing starts off with an initial height of 200. And we also have this 50 here. I'm going to play with my window. I'm actually going to look up to 300. So I changed my Y-max to 300. And that's a pretty good graph. This is where you started throwing the book. This is nonsense back here. That's all that is. It's pure nonsense. Can't write on this, but this is where time would be negative, so it doesn't make any sense. So you care about here to the right. And there's your intersection. And it is an intersection, so second trace 5 for intersect. And then we get my cursor close, and I'm going to press enter once, twice, thrice. Now, what I actually have here, and I'll draw this on a piece of paper to try and help you understand. This is kind of what it roughly looked like. There's a time of 4.56 seconds. Now, it talks about being at least 50 feet. Well, when you first threw the book at 0 seconds, the book was above 50 feet in the air because you're on top of a 200-foot building. So as long as we're trapped between these two times, the book is at least 50 feet tall. So if you like inequalities, you say 0 less than or equal to t less than or equal to 4.56. Now, the reason I'm using that inequality symbol is because of the wording at least. If it said above, I wouldn't be using an equal. If you don't like inequality forms, you can just write it as a bracket, bracket 0, 4.56, finishing it off. Close the bracket. So either one is good. Just either one of them. After how many seconds does the book splash into the water? Well, this would be where the book splashes into the water. And if you think about this being on the XY axis, this is where y equals 0. So I'm going to go back to my TI-84, and I'm going to replace y2 with a 0. Now, I actually want to talk about by hand. What we would have said done is we would have said like this, and we would have done the quadratic formula because it's equal to 0. That's how we would have done that problem. Anyways, we'll do a zoom 6. Do a second trace 5 because I put a 0 on y2. I don't know why I did a zoom 6. I'm sorry. Make that look the way it did before. I want to get my calculator about there, so second trace 5. Get my cursor down close to the x-axis, and once it's close, I'm going to press enter, enter, enter. 5 seconds on the money. So it takes 5 seconds for that book to hit that reflecting pole. And that's 11. 11's not a hard problem. It's not your first time doing a problem like 11 either. Nowhere near. All right, 12 is about a parabola. So it says it has roots at 5, -2, and somewhere on this parabola, the 0.248 lies on it. Now, what you have to do is you have to know intercept form. Intercept form is y equals a times x minus a root times x minus a root. And what you can do initially, and you should make it your first step, is you can plug these things in. Those are your roots. So y equals a times x minus 5. And when we take away a negative, that becomes addition. All right, now, it's not written yet. We need a. But we have these things right here. We have that 0.248. That gives me an x, and that gives me a y. Well, I can just plug those things in, and I'll get a. So I'm going to plug in a 48 for y, a 2 for x, and I'm going to do some math. 2 minus 5 is -3. 2 plus 2 is 4. That means that there's a -12 attached to this a, which makes a -4. So my actual equation is when I take that -4 and I put it right up there. So y would be a -4 times x minus 5 times x plus 2. There's your equation. It's not hard. Now, if you're not keeping up with me, hit the pause button. All right, use synthetic division and the fact that f of 3 is 0 to completely factor this given polynomial. There was actually supposed to be another question here, but I took it out. But this is saying that x is 3. That's what I actually use when I do synthetic division. I throw a 3 right there. I load the top with the coefficients, 2, 3, -23, and -12. And the acronym we're using is DMA bar. So we're going to drop that 2. Now we're at multiply. 3 times 2 is 6, and now we're at add. That makes 9. Then we multiply and get 27. We add and we get a 4. We multiply and we get 12, and we add and we get a 0. Remember, this is your remainder. We got the 0 because that's a factor. This is your constant. That is your x, and that is your x squared. Now what happened is we pulled the factor x minus 3 out. When we pulled x minus 3 out, we got this guy left over. 2x squared plus 9x plus 4. And your job is to completely factor it. All right? So what you're going to do is you're going to factor 2x squared plus 9x plus 4. Now when you FOIL, it takes a 2x and an x to create 2x squared. And it's guess and check, kids. I've just been doing this for so long that I don't really guess a whole lot anymore. 4 there and a 1 there will work it, because the outside makes 8x and the inside makes x, and 8x plus x is 9x. So plus, plus. There's the complete factorization of 13. And then you got this one. This one's kind of a doozy for kids, and it's kind of hard to explain as well. I'm going to do things in a manner I don't typically do it. I'm actually going to rearrange the interior before I worry about this outside exponent. I don't usually do that, but I can save myself some work if I do it now. I'm going to leave the exponents negative, okay? Because what's going to happen is I'm going to multiply by a negative. I actually just want to make sure I reduce this. That's the big thing. I think I will merge the y's together. And you can either do that up top or in the bottom, but I know I'm multiplying by negative, so I'm just going to move them down to the bottom. If I think about y over y to the negative fourth, that's 1 over y to the negative fifth. Now, if you're just sitting there confused as can be, there's a reason I'm doing what I'm doing. I'm a step ahead. Now, what's going to happen is I'm going to, in essence, distribute that exponent in. And here's what's different on this one. It also goes to that constant, that 3 out front. If it was a 1, I wouldn't be too concerned about it, and I'm not, because 1 to any power is 1. When I distribute that negative, that becomes a z to the 9th, because negative 3 times negative 3 is positive 9. This becomes 3 to the negative 3rd power. That becomes y to the 15th, and that becomes x to the 9th. Now we still have this issue. The deal is all exponents are positive. So 3 to the negative 3rd is, 1 over 3 to the negative 3rd is up high a 3 to the 3rd, which is a 3 times a 3 times a 3, which is 27. So actuality is a 27 belongs up high. 27 z to the 9th over x to the 9th, y to the 15th. And I just rearranged those two because x's come before y's. And that is 14. You got several factoring problems on this test. I'm going to go after 2 and 3 on 6x because I made the test and I usually pick things that are in the middle. So 3x and 2x. 4 is going to be 1 and 4, and you got to think hard about placement here. Or 2 and 2. But I'm pretty sure it's 1 and 4. I feel like that's going to work because that makes 8 and that makes 3. And the goal is to get to a positive 5. So positive 8 minus 3. And I guessed and I checked as I did it. Now this guy, notice the instructions say factor completely. I'm going to do this 2 different ways with you. But either way, you're going to get the same result. And there's a quick way and there's a long way. Both of these pieces are divisible by 9. So I'm going to do the quick way first. If I pull a 9, I'd have x squared minus 9 because 9 times x squared is 9x squared. 9 times negative 9 is negative 81. Now, the pattern I'm thinking about here is a squared minus b squared. It factors as a minus b times a plus b. Okay, so I'd have 9. I square in x to become x squared, so x into x, and I square 3 to become 9. Minus 3 plus 3. That's the shortest way to factor that one completely. Some kids don't like my first commandment of math about pulling things when they can, so what they would do is they would say it takes a 3x and a 9. It takes a 3x squared to become a 9x squared, and 9 to become 81. So their initial step would look like this: 3x minus 9 times 3x plus 9. And this is an OR. You might look at that and think it's factored completely, but it's not. because you skipped my first commandment in math, you created a conundrum here in this one. Both of these pieces are divisible by 3. That piece contains a 3, so I pull it. I'm left with x minus 3. This piece also contains a 3, so I pull it, and I get x plus 3. Now, I can multiply the constants together with no problem. That's where my 9 comes from. So just create a little bit more work by not doing things in the first place. Now, be on the lookout for this on a test. If you can pull something, pull it. I try not to do that too often on a test because it just leads to wrong answers, but sometimes I just don't have time to recreate a problem. 27 and 125 don't have anything in common. The pattern here is an a cubed plus a b cubed pattern. A cubed plus b cubed factors is a plus b times a squared minus ab plus b squared. You just have to figure out what a and b are. Well, a is 3x. Now, if you're just sitting there copying stuff down, you're not listening to any of the words. But a 3 times a 3 times a 3 is 27. X times x times x is x cubed. B is 5, because 5 times 5 times 5 is 125. So I'm just plugging into that. So I do a plus b, 3x plus 5, and then I square it. This is where you got to be careful. 3x times a 3x is 9x squared. If you're that kid who just writes 3x squared, it's over. Minus 3x times 5, 15x. And then I'm supposed to square that b at the end, plus 25. And that's 17. When I do 18, I'll use a different pattern. I'll do a cubed minus b cubed. A cubed minus b cubed factors is a minus b times a squared plus ab plus b squared. A is 4x, because 4 times 4 times 4 is 64. And you looked out here, b is still 5. Now, if you do enough of my homework, if you actually do it, you'll notice I like certain numbers, so be familiar with these numbers. And I'm just going to plug in. I'll have a 4x minus a 5. I'm supposed to square this piece. It's going to be 16x squared. My next sign is plus. 4x times 5 is 20x. Then I'm supposed to square the 5, and I'll get 25. For y'all, that's going to be rough because y'all haven't memorized your patterns. Of course, most classes don't. Now, this is a new question. You haven't done anything like this in your homework. It's one of those rare situations where something shows up on a test that you actually haven't done in class for the most part in Algebra 2. It is kind of rare. I made it like this so that you couldn't just cheat with a calculator. What I'm going to do is I'm going to focus on that 3x plus twice I and 2x minus 4i. Now, whether you're Christian or not, Jesus would foil that piece. He'd actually probably call it something else. He spoke a different language than we did, Aramaic. 6x squared minus 12xi. Actually, they didn't have algebra. Plus 4xi minus 8i squared. So Jesus the carpenter may not have done this, but I'm sure the ascended version could. And I'll leave that xi there. Now, there's a lot of work that can be done in here before I worry about this xi out front. We've been talking about this a lot lately. You're still not getting it. A negative 8i squared is a negative 8 times a negative 1, which is a positive 8. So I'm going to go ahead and throw that in there. because if I don't, I'm just going to create myself more problems. Oh, I need to add these terms together right here. Negative 12 and 4 makes a negative 8. So negative 8xi. Then I have the plus 8. And now it's just the distributive property. It is a little confusing here, but I'm allowed to multiply like terms. So x times x squared is x cubed. Don't forget about the I. Now when I get here, something interesting happens. Negative 8x squared is x times x. I times I is I squared. So that piece is going to have a cleanup job to it as well. And then plus 8xi. Sadly, that's not your final answer. We just talked about that piece right there. That's a negative 1. So 6x cubed I plus 8x squared plus 8xi. I might make the test one a little easier, because that's a pretty rough problem. Usually in a normal class, there's only about 5 or 6 out of about 80 or 90 who will get it. In your group, it's probably going to be about 1 or 2. So I might make that one a little easier for y'all. Here's 20. It's a long division problem. And when I created the problem, I didn't realize it would be that much different than what some of your homework was. But it's too late because I've already made the problem. So sorry about that. Of course, you guys should know how it gets set up. And you have to do it with long division. I mean, there will be a place on your answer document for me to see it. But the inside gets loaded with the dividend, 3x squared, cubed, plus 4x squared minus 3x. Now the outside, I don't normally talk about this, but I think when you do this problem that having a placeholder in the divisor actually helps. You can try without the placeholder and you'll see, but if you don't put the placeholder there, you tend to get things kind of out of order up top. And we may have to introduce placeholders as we need them. That's a possibility. You'd like to see a constant next. We might actually put something there. But the first goal is turn this x squared into 3x cubed. And you do that by multiplying by a 3x. Then we just invoke that distributive property. We get 3x cubed plus no x's. Oh, look at there, there's a big gap. Plus no x's. Sorry, no x squareds. X times x is x squared. Plus 6x. That's kind of why I put the placeholder there. So you wouldn't put something in the wrong spot. I almost did still. Take away, 4 minus 0 is 4, so 4x squared. And a negative 3 minus a positive 6 is minus 9x. Now, we're going to introduce a 0. And we're going to bring it down because we're actually going to need it. The goal is turn x squared into 4x squared by multiplying by 4. So when we do that, we'll have 4x squared. There won't be any x's plus 8. And we'll just subtract on down. We'll have a negative 9x minus an 8. And that is our remainder. Now, if I was to make this multiple choice, which I might, I don't know, I have to build your test for speed. If I was to make this multiple choice, the answer choice to this one would be 3x plus 4. And I actually would not say plus here. I'll write it out initially as plus. I'll try to explain what's happening. But it'd be the remainder over the divisor. But I actually would not leave it looking like that. What I can do, when I think about negative 9x minus 8, is I can pull a negative 1 and rewrite it as 9x plus 8. I'm going to pull the negativity out of the numerator. Because I can. And the truth is because you should. That would be what your answer looks like. That's it. Pass the test, pass the class, kids. That's all you got to do. Pass one test.